The three types of expandable devices are based on a new working principle, that is compression of the vascular stump between inner nitinol wireframe and outer structures, either external ligature as in type 1 and 2, or nitinol wireframe as in type 3, instead of sewing with full thickness perforations of the vessel wall. This is obviously simpler, quicker, and also more efficient, since the integrity of the vascular stump is preserved and the anastomosis is then immediately competent, airtight in fact, and not dependent by the integrity of the coagulation mechanisms. Type 1, previously connected to the tube graft, is usually used for the first anastomosis that can be either the proximal or the distal one. Temporary aperture fixation is easily achieved by bending the distal end of the actuating guide. Obviously, user tourniquet minimize the clamping time. Then the graft length can be adjusted as required, and type 2 used for the second anastomosis. It's important to consider that, contrariwise to standard suture, with this type of coupling, hemostasis and coupling stability rely on different mechanisms. Hemostasis, in fact, can be achieved by a ligature tied up to a maximal intravascular pressure, but that pressure, however, or even much higher pressure, may not be sufficient to prevent the expandable device to slip out the vascular stump. So is much safer to add transfixion suture with a second ligature. There are many ways of doing so. Here one is shown. This phase anyway could be carried out after the circulation is resumed. Final aperture fixation is carried out this way, and it can be then removed. In device type 3, an external nitinol wireframe realizes the aortic stump compression against the inner sleeve, allowing fine control of the pressure that is then applied along a straight band instead of a line as in ligature. Needles on the outer surface of the inner sleeve can efficiently block the vascular stump. However, safety in and out transfixing suture may add further guarantee of permanent stabilization of the coupling. The inner and outer sleeve can also well comply with the conical orientation of the vascular stump in the concavity of the arch, allowing to extend there the anastomosis line as with manual suture. Even in these conditions, the anastomosis is immediately even airtight in spite of this geometrical distortion. Airtightness that cannot be achieved by standard suture, obviously. In small diameters type 1 device, the inner dacron layer folding at incomplete aperture may significantly reduce the vascular lumen and then interfere with the perfusion. For this reason, we prepared these devices with the outer dacron layer only, and this allows to apply this coupling method in vessel of 6 mm in diameter or larger. Here the assembled graft for total arch substitution with elephant trunk for the swine model which consists of two Type 2 devices and one Type 3 sutured on Dachron tube 22. The outer sleeve of Type 3 device can be rotated backwards when the inner sleeve is retracted, thus enhancing exposure of the aortic stump. In the open aortic arch specimen, the preparation of the distal arch vascular stump is not different from that required for sandwiching with standard technique and sectioning in its entire circumference. But obviously, with this method, sandwiching is carried out at once with the true anastomosis. Supraortic trunk cannulation is very easy and quick, and at least in this normal specimen, the length of the prosthesis branches is ideally kept very short. The human model shown here is prepared with three Type 1 devices on 34 mm tube graft with Type 3 for distal arch anastomosis, allowing 55 mm of maximal diameter. After having compressed the vascular stump between the Type 3 sleeves, it is possible to reduce the anastomosis diameter toward that of the main tube. Obviously, Type 1 devices prepared on Coselli's tube branches can be ideally applied in extended thoraco-abdominal substitution. This modified Type 2 device can be activated independently at each side and can be bended up to 19 degrees to be used for ascending aorta substitution or in case of isthmus repair.